Okay, today we're going to look at different ways people should describe data. So turn to page 42, and for the first part, there's really not anything for you to write down, just a matter of paying attention. So on page 42, we're going to look at the effect of outliers. Now remember, an outlier is a data point that is very different than the others. And so in the top box, you can see that there's no outlier. All the data is pretty close together. You can see in your box plot, everything seems to be spread out pretty evenly. They did the box plot underneath the number line, so they could use the same number line for both. In the second one, they have a small outlier. It is on the left side. It is the number 1. It is definitely different than the other numbers. If I have a small outliers, they reduce the mean, so they bring the mean down. So whenever I have an outlier, I'm better off if I want to say what's the best way to describe my data. Because they reduce the mean, the median is better to use when I have an outlier. Okay. If you look at the next one, I have a pretty large outlier. That 28 is a lot bigger than all the other numbers. It's going to, because it's bigger, it's going to make my mean go up by quite a bit. So again, because I have an outlier, I want to use my median as the best measure of center. Okay. So what I want you to get out of this on this page, they've done the calculations for you. We're not going to walk through those steps, but when you're looking at a data description, if you have an outlier and somebody asks you what measure of center is best, well, measure of center, you have 3 choices: mean, median, and mode. If you have an outlier, your answer is always going to be median. If you do not have an outlier, like the one up at the top, your answer is going to be mean or also mode if the data point in the middle has more than the others. But sometimes our modes are off to the side, or we can't tell what the mode is. And in that case, we would just say the mean. Okay, down here in the bottom, they kind of give you a rule of thumb. If you're not sure when you're looking at a picture if something is an outlier or not, it says figure out your IQR. So in this case, 14 minus 10 is 4, and multiply it by 1 5/10. That is 6. So then I look on the picture and I say, well, 6 more than 14 would be 20. Does that upper point, is it larger than 20? No. And then I would do the same thing on the bottom end. I would say 10 minus 6, that's 4. If my lowest point were smaller than 4, then yes, I would have an outlier. Okay, looking at page 43. All right, so if we have a symmetrical bell-shaped curve, which is the very first picture, row across the top, you can see what it would look like as a bar graph, a dot plot, and as a box plot. The data values cluster in the center. They skew equally to the left and the right, meaning it's symmetrical. In that case, your median and mean are probably going to be the same. Not always, but they're going to be very close. But the best measure of center, as you can see in that back last column, is the mean. Okay, if you have a symmetrical U-shaped, this doesn't happen very often, but if you do have something like that, so it's symmetrical, like a butterfly, but it dips in the middle and then goes back up, and you can see what that looks like in all 3, then your best measure of center is the mode. Okay? So you're going to tell people the 2 modes on either end. If it is skewed to the right, so we're in the middle row going across, you can see what that looks like as a histogram, as a dot plot, and as a box plot. Your best measure of center, because it is skewed, is the median. If it is skewed to the left, again, because it's skewed, you can see what pictures of all 3 descriptions would look like, but because it is skewed, we go with the median. If it's uniform, that means there's the exact same amount of everything, then our best choice is the mean. Hey, on page 44, data variability measures how spread out the data values are in a data set. So we're talking about the spread of the data. And those can be answered in different ways. The three different descriptions for spread, somebody could use the range, the IQR, or the MAD. Okay? And you've got a couple different pictures there. And we're trying to see if there's a lot of variability to it. If you look at the stuff for city A, it has not very much variability. The range of 18 is somewhat small compared to the mean, which was 76. The box and whisker plot, it's compressed. It's not very spread out, meaning the data are all close together. The IQR is 10, which is small compared to the mean of 76. And then the mean absolute deviation of 5 is small compared to that mean of 76 and 5/10. So that's a city with not a lot of variability in their temperatures. Now, if you go to city B, their range is 38 compared to their mean of 76. So it's got a lot of variability there. That 38 number is a lot closer to the 76. The box and whisker is a lot more spread out as compared to city A. The IQR is 26. Compare that to the mean of 76 versus if the other city, its IQR was only 10. So it tells you this one's a lot more spread out. And then the mean absolute deviation is 12. That's somewhat small compared to the 76. Okay, now if you look at pages 45 and 46, you're going to use a highlighter, pencil, and just circle, but you're going to have to choose which one is the best answer of your answer choices. So on the first one, it says by looking at the pictures of the data displays, we want to determine if there are any outliers, describe the shape, and identify which form of center and spread or variability we should use. So I'm going to do the first one with you. So make this a little bigger here on the screen. So I've got a dot plot. So when I look at this dot plot, the first thing that I'm asked is there an outlier? So look at those dots. Is there one that's a lot different than the others? And the answer would be yes. That one over at probably 25, much smaller. Now I look at the shape. Is it symmetrical? No, it's not. Is there more data on the left side or on the right side? Well, there's more on the right. So that means it is skewed left. Hey, now we've talked about on the last couple pages, if it is skewed to the left or skewed to the right, that means I am going to choose the median because I always use the median when it is skewed. I use the mean when it is symmetrical. Now these correlate to each other. Which measure of variability of spread is best? If I want the median, so I go back to what I do for my center, the median goes with the IQR. So guess which one, if you choose mean, which one's going to go with that? The MAD. Because mean and MAD go together and median and IQR go together. Okay, go ahead and continue highlighting or circling on this page and the next, and then turn them in when you're done. Make sure to grade using the key.